Hello, hello.
You watching One Piece? You say that, but like...
Well, it is if you're actually in one. If I was going to get to it.
Yeah.
Alright, that looks pretty convincing. Do I have noise?
Well, it is if you're actually in one.
Let's set up a feedback loop here real quick. Alright, that looks pretty convincing. There's going to be a feedback loop there. Alright. Let's mute. Whew.
Is there like a thermostat?
I love one of my applications and said, how's it going next time? So now you're trying to look backwards, fucked up. So it's like, before I submit the application, I'll just make it naturally.
I think they're European. It says Swiss on it. This gives me a hint as to why it feels the way it does in this room. I think we'll just set this over here and do that. I like to think of myself as nature healing, right? I'm part of nature. And
I'm not a very good part of nature. Well, I thought it was self-explanatory.
I appreciate that the sentence just ends when it's done.
Here for a good time, not a long time.
I spent way too long on that thing. I made a way I could make randomized unit vectors. And then I just made a list comprehension.
You just tested like all of them?
I tested 10,000. And I was like, I'm not guessing and checking. I'll just
That
do 10,000
is
random ones.
hilarious. I think I just got a good one though. I think I got the best of this. $300 for 1 square foot of limit. $300 for 1 square foot of limit. It's crazy.
Good afternoon, students.
Good afternoon, Professor.
There is class today. I will be in Salem at 2:50. I actually got here slightly before 2:50 today and stopped by a drinking fountain. So I wouldn't say well hydrated, but I'm less well hydrated than I couldn't not be, right? Separately, there will not be class on Thursday. You can still come here if you like. Are any of you going to come? That's what I thought, right? No? You will not be here on Thursday.
Oh, okay.
Okay, all right. Sorry. That was it.
You can't stop me.
It's true, I won't be here. In exchange for me not being here on Thursday, I'm treating you all to a free bonus lecture. Before I do that, I'm going to share some updates to the way the macros assignment was presented. The due date is updated. And there's a lot of questions about whether I mean right or left rotate, because I didn't say that anywhere in the instructions. You were supposed to intuit I meant right rotate. But because you didn't do that, I have said you need to do a right rotate, okay? All right, I added that. And then I added a viewer to the tester. For me, it was important to show you an example of C code that could run without any libraries, so this is written without standard I/O, among other things. But I've also included this nice little script right here. Look how cute it is. There's no code factorization at all, right? That could have been a for loop. It's not. I did that for you. You're welcome. If you don't appreciate it, that's okay too. So this will show you pictures, and what will it show you? It'll show you what choices, medians, and a series of rotates look like, right? I'm going to say this out loud. This is a hexadecimal numeral that is not binary. It only contains zeros and ones, because I picked my two favorite numbers, which are 0 and 1, right? If this is confusing to you, I have provided the code for you. Simply change all of these 1s to A's, or F's. I like A's better than F's. Can I hear it for A's, students? Can I hear it for Nathaniel Hawthorne's Scarlet Letter? Perhaps? Yeah? You don't know. Okay, all right. That's the homework assignment. Do not bamboozle yourself. It is 3 lines of code.
I mean, you're not wrong. But...
I'm not wrong. I am the best type of correct, which is technically correct. And the second best type of correct is actually correct, which I'm not, because it's actually 0 lines of code. So I've been thinking about all of you fondly from my stony winter castle in the freezing north, known as the Matisse. It's named after a French artist. I asked them to change the name. They wouldn't do it for me. And I was thinking, I don't know that all of those students know what binary and hexadecimal and 2's complement are. And you do not, in fact, have to know that stuff for the assignment, but I thought I would teach you since I maybe have a free bonus lecture. So today I'm going to do a series of just guided talks over the way in which bits and bytes compose numbers, which might be of some use to you before you get into the secure hashing algorithm 2. Before I do that, because this is a free bonus lecture, does anyone have any questions they want to ask about anything? It can be related to the class if it has to be.
What's your favorite
I guess probably whatever the background color of this is, which I think is hex 010101. Yes.
What was your most impressive lift when you did powerlifting?
I pulled 300 something, but I don't remember what it was. And yeah, because I almost exactly hit a 2x body weight deadlift, and I don't remember how much. I did everything body weight relative, and I don't know how much I weighed, if that makes sense to you. But I'm pretty sure I was 165, so that means I should have lifted 330, right? Yeah. And then I was like, is this going to cause my spine to explode? And read one exercise and health science paper and instantly stopped lifting and started doing triathlons instead. Okay. Any other questions? Okay, I have to issue a correction to a previous statement. It has been pointed out to me. I said Morgoth the Omen King is the best Dark Souls boss. That's incorrect. I was referring specifically to bosses within Elden Ring, a derivative lesser video game based on the Souls series but has nothing else in common. The best Dark Souls boss is Twin Princes. Thank you. Okay, announcements. Welcome to CS 276. This is a desynced lecture. There's no class on Thursday. We already talked about that stuff. Today we're going to talk about endianness, casts, and 2's complement. And I had no idea how hard those words were to say until I just tried to say them in front of you. Endianness has 2 adjacent ends. Who cooked that up? All right. So this is endianness, and this is the worst. Okay, well, I thought this was the worst, and then I tried to do long division. And it turns out long division's the worst. But the last 5 letters of this word are N-N-E-S-S. What absolute madness is gripping our society when that's going on. So let's talk about computers. Anyone in here a big fan of computers? Can I get a whoop whoop for computers? Yeah, that's what I like to hear, right? We like to have a good time in this class. So here's an example of some things that computers are good at. I hear they're good at numbers, right? Have any of you all heard this, right? So the most popular, I think, programming library in the universe is NumPy by like a factor of 10 or something. It's the basis of all machine learning. R is just NumPy without Python, and that actually makes it popular enough to be its own freestanding programming language, which is pretty impressive. There's this language called Julia that no one's ever heard of. Has anyone ever heard of Julia? Yeah, oh, we've got some Julia appreciators. What's Julia used for?
Scientific computing.
That's a made-up word. Okay. It seems like biologists use it. There's also this thing called Stata. Any of you heard of that? Okay, and then there's SAS or SAS. That's from where Professor Gore and I are from. That's a North Carolina product. And I didn't put it on here. I should have forgot. I should have MATLAB on here. We all love MATLAb.
That's what Julia was made to replace.
Yeah, did it work?
Not really.
Yeah, you know what replaced both of them? Python. Okay, so I want you to imagine for a moment, cast your imagination, entertain the possibility of having a thought in your mind, okay, right? So I'm thinking about something, right? And what I'm thinking about is a 3-digit decimal representation positive integer. Doesn't matter which one. The natural one to think of is 276, because that is the communal 3-digit positive and or non-negative. We're not going to get too into that. And so one of the things I've noticed is that a lot of humans are taught numbers in this thing called kindergarten. And then they're tricked into thinking numbers exist in digits. And I found this out when I was hanging out with my friends in Portland in the MSCS program. And one of them printed 2 in binary, and it said 10. And the person said, "This computer's clearly wrong. I asked it to print 2 and it said 10. And I was like, ah! 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 And then I stopped doing that and explained binary. But you all know binary already because you took CS 151 and it was in there, right? Everyone nod your head because you all know binary, right? Okay. So we're actually going to do an exercise right now. I have 10 fingers and thumbs don't count, so I have, fortunately, a power of 2 fingers, right? So we're going to pair up with each other, and you're going to hold up a non-offensive gesture using these fingers, and the other person is going to tell you what base 2 numeral that represents. So, like, what's this one?
Oh.
Right. I don't know either. It's kind of hard, right? So we're going to practice a little bit. You can start with one hand if you want. It's much easier with one hand. This is 9, right? Okay. So we're going to take 5 to 10 minutes doing this, and we're going to have a good time, okay?
That is slightly less resistant, and that's Oh, this is too bad.
Yeah, we're talking. I'm from the same track.
Yes.
You're really making Jimmy.
Right, binary is base 2, so every
You can tell just because every base is 1 down, every base is 1 down. So it's just
Three,
yeah.
that's beautiful.
Yes.
5, that is
And so do I ever actually convert you to binary decimal method? No, I still don't have
they do fractions just by integer.
This is 128, 2, 4, 6, 8, but then there's all 1, 2,
128, 16.
Yes, no, but I'm saying 144, 245, the fact that 1 is not 0. I get it in my head. I don't know how to say it.
Yeah.
That makes it.
Voting point representation is magic and What?
But you don't know.
Okay, there's something called a mantissa and an export.
I actually learned about this.
And one represents, it's basically really good scientific.
Yeah.
The scientific notation in terms of twos.
It's in terms of why would it be in terms of tens? This is a computer.
Yeah, fuck you. Scientific notation. Fuck you.
2 to the power of, and you can get back the scientific notation barely fully just with the scientific notation, right? And that's basically how it goes.
What if instead of we ever taking decimals, we just instead make the units? So we instead are working with meters and we need to be precise and for 100th of a meter, we make 100th of a meter 1.
That makes sense.
That's why.
But then
I
once
mean,
you
if you
start
want
to
things
use
to be
whole
fast,
numbers,
that
they're
is
whole
what you
numbers
do.
and what else.
If you want things to be fast, that is what you
Literally.
do. See, the problem is, when we're talking about binary decimal, why would we convert it back to decimal? We already have an answer in binary. If I can do addition and multiplication in binary, it's way easier in binary.
Finish your ternary.
No, I never finished. I've never tested the first one to be fair, that one could still work. I'm actually pretty confident about that. No, the first version, because I started the second version that was way more advanced, and it turns out I was basically trying to write a 64-bit emulator, which is pretty hard. Except it's a 27-bit CPU emulator, which I based my instruction set off of ARM, which is a full-fledged actual instruction set.
Trying to do the whole instruction set.
Well, yeah, how else would you write it?
I mean, yeah, if you're writing a computer, it's just a lot.
Okay, I didn't do everything, but I did do more than I should have. I can show you the sheet, the Google sheet that represents it. This is the sheet that represents the easy one. So this is the sheet that represents the
I saw the one that made a computer. I saw one that made a computer in the game.
You know, that's the hard one.
I watched now that you said it to me. It's really cool.
There we go. This is the one for the
I'm gonna pull it up.
represents all the
The game of life and life.
Oh yeah, life is great.
Yeah, speed up.
But it's actually typical that they don't have a quicker speed on YouTube videos.
Yeah, my brain would be totally fried if they did. More than it is already.
No way.
Shut up.
Those things that spin around are. That's really cool.
And there it is. Isn't that really cool? That's really cool. And then this is edited, but this is life and life and life, and it's an infinite loop where they edit it and it just keeps going.
Like, it doesn't look too bad when you think of it this way. And you can look at it simplified like this, even.
They can be really cool again with finance they just talk about. But also,
What does that mean in like normal people speak?
this.
Let's see.
This, but like more, sometimes more applicable. It's like little dudes that make your computer work. Yeah. Like imagine if
No, that'd be awesome.
when you program instead of programming things normally you program with Carol and then Carol did things.
That would be the worst thing
That's kind of
ever.
how I did Enigma. Like, I did it as a
Oh, come on, Windows. What are you doing other than starting the kernel of a good operating system? It's sleepy.
I'm sure it's fine.
What are the odds it's not fine? This laptop is hot. It's cooking.
See? It's fine.
Oh dear. So it's very easy to see what the translation between binary and decimal values. That's 153, and it's not too bad to go the other way with bin. Everyone loves 100 for some reason. So that is a 1 in the 64s and 32's place. 32 plus 64 is 96, so we also need a 4. So there are 0 1s, 0 2s, 1 4, 0 8s, 0 16s, a 32, and a 64. And that is, I don't know, binary 100. Some of you may be into format strings. Do we have any format string appreciators?
Woo! I'm a format.
Unfortunately, I have no idea how format strings work. Do you do something like this?
Yeah.
It's not going to work if you use the
Oh, I have to not use oh, I have to use little quotes. Does anyone know how Python works?
Or the second quote has to be.
Just like in English, you have to like
This seems fine, right? This seems totally reasonable. Okay, so that's a way to move them around. And I think you can also do translation with format codes.
What is X?
Hex,
Oh, X, okay.
which you can tell because I printed a 10 then a 16.
He said ASCII.
I said maybe ASCII. I was not that calm.
How would I do ASCII? I don't know which one is ORG and which one's chur. Int val? That's an int? Oh, I probably need chur, right?
Yeah, sure.
Let's do a larger value. There you go. You can do some ASCII if you want. Oh, I shouldn't be using hex, right? There we go, D. Because D is the 100th letter of the alphabet. So this should all make perfect sense to us and shouldn't be confusing at all. Oh no! That's the grade I got on my binary exam in undergrad. Okay. What I hope some of you realized is, wow, I can express really large numbers in small amounts of space. And then I hope the next thing you realized is, I could use this to destroy the Nazis. And that's what Alan Turing did. And that's why they named the good version of the Nobel Prize after him. The bad version, of course, being used for real science. Okay, so early computers, my understanding, and I've seen one of these at the University of Pennsylvania. For some reason, these people created a different, like, vacuum tube, right, which is some piece of hardware, to store different digits. So if you wanted to store a 3-digit number, you would create 10 different vacuum tubes, each for 0 through 9, and you would do this 3 times, and so you would need the ability to hold 30 different values, many of which were mutually exclusive, in order to represent a number as large as 999. This was an obviously bad idea that was defeated by binary. To represent all of the possible values, you only need to go up to, I think, like 2 to the 9th or something. Is that true? What's 2 to the 9th? Okay, that's the...
512.
It's 512, right? Yep, so 2 to the 8 is 256, which we know because there are 255 possible ASCII or UTF-8 values. There's 127 ASCII values. So we're accustomed to 255. We've seen it in things like color maps. We've seen it in CSS. We've seen it blah, blah, blah. We can represent that with 2 hexadecimal digits. That goes up to 255, which means by going up to 2 to the 9th, we have a 512s place. And that 512s place is one more than the rest of the numbers we can hold there, which means we can express 511 in those other places. Which means with a combination of that 512 and going up to 511, I can represent any 3-digit decimal value using just these. I think I have 10 values there because this is 0 indexed and goes up to 9, right? So if I were storing values in decimal inside my computer, I would need 3 times as many transistors to store the numbers as if I used decimal. And I think as if I use binary. And this gets worse over time. It's I calculated this by taking the log base 2 of 999, which you don't have to do it that way. 2 to the 10th is very close to 1,000. It's 1,024. That's a good number to remember. So that means if someone needs to know the log base 2 of the population of the United States, there's 300 million people. 300 is about 255, which is 2 to the 8th. And then each of those thousands in the million are 2 to the 10th. So the log base 2 of the population of the United States is in between 28 and 29. And that's not that hard to figure out. I don't know when you're going to have to do this, but this is a good way to compute how long your social security number would be if it were in binary. So here's an example of representing a number not dissimilar from what I showed you, but it has a differential index, right? So I think I did this one. Rock on. Okay. I need to stop listening to Avenged Sevenfold. It's going to be a problem. So we agreed that this was, I think, 153. When this was representing the 1's place, it is now representing the 2's place, which is easy. That is a either left or right shift operation. I don't know how operations work. Hold on. Help. Okay, that looks good. Which is going to be 306. So this represents the binary numerical value 306 because 2 to the 8th is 255, 2 to the 5th is 64, 2 to the 4th is 32, and 2 to the 1th is 2. So if you add up 2 plus 64 plus whatever I said, does this all make sense? Y'all locked in? I don't want to have to do addition up here in decimal. Ugh. Okay, so this leads to a slight problem that I spent the last 3 weeks trying to solve, and I'm going to ask you to solve that problem in 1 week and 2 weeks. This one?
Why does the table look like that?
So these breaks here are caused by me not knowing how to make things. You can look at the source code for this. This is a graphviz dot graphic. And what I actually think I needed to do is there's just nothing in these boxes. I think I should have put a non-printing character there, and that would have smooshed everything together correctly.
The ones in the boxes slightly different sizes.
I know, right?
It happens.
No, hold on. There.
That's the best one.
And it also happens to the worst of us, which is me. Okay. Ah!
I was
Is that where I'm trying to go? Does anyone know what I'm doing? Indy knows what I'm doing. Indy, can you tell me what I'm doing?
You're going on to GitHub to look at something.
We're going on to GitHub. We're gonna read a lot of Markdown. We're going on to GitHub. Gonna read a lot of Markdown. Okay. There it is. Okay. So this is what the graphic looks like. Apparently, this way of representing graphics was cooked up by people at AT&T Bell Labs shortly before they invented Lisp, or perhaps shortly after. So it is old and decrepit and works poorly. Look, it's my favorite color. Or wait, no, maybe this is my favorite color. I said the background. It's pretty easy. It's, never mind. It's not easy. Okay. Always just speak with confidence and be wrong. Is this how you spell absence?
No.
Moving on. Okay. So some of you have heard of this direction called left. Any of you heard of this?
Yes.
Which direction is left? I'm sure we can all agree. I think it's this way.
No. Stage left. Our left. It's that one.
So it turns out what we should be using is port and starboard, right?
Mm-hmm.
Exactly.
That will
Amen.
not have the
Yeah.
exact same issue for sure.
And as the captain of the ship of CS-276, I have decided the direction of CS-276 is this way, and therefore that is left. I love being not elected. Yeah? No, I don't. I meant to mean that, but then I didn't, so I don't. Okay. So here's a fun question. If you're a computer and I ask you to hold my favorite 3-digit number, which is, of course, 276, because you're all my favorite students, each and every one of you. Is that I think I can say that. That's okay, right? Is anyone offended by that? I can't ask you if you're offended because you won't feel comfortable speaking up. Okay, so an example of something that is not my favorite is the least significant bit, because it's not significant, right? It's only worth 1, right? So I probably don't even need to factor that into my calculations if I'm doing, for example, mixed precision arithmetic. I have noticed that sometimes when I am writing numbers down to transmit the information to other humans, I start with the most significant numeral, not necessarily a bit, but a digit, right? So in the number 276, 2 represents a larger value than the 6 because it is shifted over and multiplied by 10 squared. Now, this raises the question of, should we put the biggest value or the smallest value in the leftmost position? And nobody knows. So I think probably it seems natural to you to lead with the hundreds place, and I'm going to try and take us on a journey that will cause you to question everything you've ever known. How many of you have heard of languages? And what is the best language?
C.
C89, that's right. And why is it the best language? Because I said so, right? There's not actually a good reason to say it's the best language. Okay. So I think when I'm talking to other people, you may have noticed earlier I used the example of the population of the United States. I only specified some of the most significant digits. In fact, I only specified the one most significant digit. I said 300 million, only specifying a single digit, right? And you didn't all, like, start pelting me with rotten fruit when I did that or something. Does anyone know the actual population of the United States? It's like it's over 300 million, right? Uh-oh.
Raised it to 34.9 million.
Because if it starts getting too close to 50, I'm in trouble because I truncate instead of rounding, and people hate that. So anyways, I only gave you the one most significant digit. I did not say the ones digit of the population of the United States is 7. We don't care about that, right? So this notion of more significant values being more important and perhaps coming earlier in sentences makes sense. There's the cognitive theory of primacy effect, where we might want to lead with information we think is important, which is why at the start of the semester I taught you that C89 is a good language, and then I'm going to teach you a bunch of stuff I don't care about for 12 weeks, and then at the end of the semester I'm going to teach you that Bitcoin's bad, and that's the only thing we're going to remember from this class, right? So 200 of something is closer to 299 of something than 0 of something is 29 of something. Is that true? I think that's the negation of true. Okay, in programming, we often lead with the lowest numerical index. For example, if I have the string 276, the 2 is in the 0th place of that string. Uh-oh, you may be thinking to yourself, that's going to be a whole entire mess that someone will have to deal with in approximately 2 weeks. And you are correct. That is what I am going to make you do. So, when we are working with, for example, a programming language, we would probably affix the label 0 to the 2 in 276 and affix the label 2 to the 6 in 276, even though those indices are inversely related to the significance of the value. So we have an anti-correlation. This is bad and should stress us out. So we can look at this, and we can see that the 0th position of 276, here, I can just run this code. Is this going to work? Wait, int is not an object? Oh, I did the thing where I mixed my quote types. Oh no, this is already mixed. Look at that. I have a plan. I have a plan. Would you look at that? If we look at the least significant value of 276, we see that it is a 6, but if we look at the 0th index value of the string 276, we see a different numerical value. So we have to become accustomed to thinking about whether we are expressing things for linguistic human readability or whether we're expressing things for a way of iterating through a list. I think it is odd to begin iterating through an integer beginning with the most significant bit because that's not how I do addition, and computers are good at doing numerical data, like adding things together. And usually when we add things together, we start with the ones digit and then we carry over. Because we never start before the ones digit because we only use integer types. So we're going to do a motivating example caused by my aspirations as a budding content creator. This gets very not very annoying, when trying to move numbers around that don't quite fit in some number of bits. So let's consider the example of the Instagram follower account that I am striving for by December 2025, which is 123,456. What is the log base 2 of that value? It's approximately 128 times approximately 1,000. 128 is approximately 2 to the 7th. 1,000 is approximately 2 to the 10th. So that is approximately 2 to the 17th, which means I need 17 bits to hold it in, which means I can't store it in an 8 or 16-bit integer, which means I can't store it on my computer prior to 1995. This is exhausting for me because I want to be that popular in the past before I start kindergarten, right? My slide here says we should boycott Meta or we should follow me. I think that is contradictory. You should not do both of those things. You should do one of them or the other. Okay, actually you don't have to do either of them. I'm not allowed to tell you have to follow me. Okay, let's keep it moving before I get in more trouble than I already started. I'm introducing the function scanf. Unlike printf, you just put the f at the end because it's really hard to say printf but it's really easy to say scanf, so I just say it. It is not really the inverse of printf, but it's not really not the inverse of printf either. Let's take a look at an example and see what we can do with this. So let's open our good friend Vimothy. We'll go into insert mode. We'll include standard io.h. We'll do an int main. Let's see. We're going to scanf into... We're going to scanf. Okay. I'm going to scanf decimal value integers, because I'm going to get 1, 2, 3, 4, 5, 6. I'm going to print the integers. We'll come back to that later, I guess. We'll return 0, and then we'll close our parens. And this has an obvious problem with it, which is that these scanfed integers aren't going anywhere. Let's demonstrate this by saving our work. No file name. Does anyone who knows how to use Vim know how I can save this? Really? You can just do it. No, I want to save as.
Okay, so you can do W then name the file name.
W already have a name.
Type the name.
Just do save as.
I'm doing save as. Why are you all pressuring me to do things I'm not comfortable with? I'm being... It is true that I am the one that told us to use Vim, and I regret it every day. Okay. Because then I have to use Vim. Which is my least favorite thing. Or we'll just gook it. Oh no! Oh no! The format %d expects a matching integer star argument? I wonder what that could possibly mean. So we have used... Wait, did you say something that made sense? No. Okay. If you start mumbling vaguely at me in the front of the room, make sure it makes sense, because I will have to try and respond to it, okay? You're taking on great power by interrupting me, and when I'm one train of thought is desperately trying to leave the station. Okay. So we need some %d int stars, which sounds like a sick band name, %d int star. That's cool. Okay, but I think, this thing successfully compiled with warnings, so we should just run it and see what happens. That looks pretty bad. Cool. All right, let's fix this up. And here's the example. Where's the bottom of my code block? Did one of you steal that? Is it showing up on that screen? No? Okay. Oh, it's back. Look, there it is. And you got a little scroll bar. That's fun. I think that's fun. Is everyone having fun? Remember, fun is mandatory today. Okay, let's create some int stars. I think there's more than one way to do this. I'm going to show you the way I would do it if I were you. Where's Vim? Oh, God, I have to... Typing. Oh, it's my nemesis. Okay. Okay, so let's make some int stars, right? Wait, where's my cursor? Ah! Okay, it's fine. If you know how to use Vim, please judge me harshly, right? Yeah, I know. That's why we're here today. What is there like a My Chemical Romance song that starts "Dearly Beloved, we are gathered here today" or something like that? Did I make that up?
Yeah.
Whose song is that? It's one of them that my friends listened to in high school while I was listening to Bach, which is why I'm a sicko now. Okay. So we need somewhere to put our integer. So I suggest, why don't we make some buffers of size 1? And I'm going to call them A1 and B1. And you're going to think, Calvin, isn't there another way to do that? Yes. Jacob, are you raising your hand or vibing?
I'm raising my fifth Prince. That's the song.
Wait, what'd you say?
The song you're thinking of is by Prince.
It's by Prince? I'm so cool! That's so cool! What song is it?
Let's Go Crazy.
Okay, I had no idea that was the song. So, okay, I'm not that cool. So I'm going to create buffers of size 1, because that's how I think of this in terms of Python, where you create lists of length 1. I'm going to save this. I'm going to gook it. and I'm going to scamp it, and I'm going to yout it. And I get the same behavior, but I don't get a warning. So they're letting me off without even a warning, right? This is why I am poorly behaved. Okay, let's show you one example of something that is a little bit cooked. So you could put, and my impression is, what do I want to do? My brain stopped. Okay, all right, let's do stars. And maybe this is a good or maybe this is a bad idea. Let's gook it and let's ute it. Ooh, that's bad. Oh, that's bad. Oh, that's so bad. Oh, that's the worst. Gosh, that's the, what happened? What'd I do? Int star a and int star b are uninitialized variables, and I ask to write to them. I'm going to store a in a location that does not exist. That means I try to store something in a location that does not exist. I get a segmentation fault. This is bad. We are going to deal with segmentation faults more in time. I've made the executive decision to reorder our instruction to deal with memory later in the course, because I think cryptography is more interesting. What this means is that the standard methodological approach I would like you to use when you encounter seg faults is to switch to using buffers. So use buffers for everything unless you are passing something as the argument to a function, then transiently refer to it as a star, but always make sure there's a buffer around. We can think of this in terms of actually, Jimmy tricked me into thinking about it this way, probably by accident. You can allow a called function to borrow memory from the calling function. So we can allow scamp to borrow memory from main, but we can only do that if we have memory in main that scamp can borrow. And the way we create memory in main that scamp can borrow is by creating a buffer. Otherwise, we are just having the description of what memory could be rather than having actual memory our friends can borrow. This is the difference between having a recipe for delicious vegan chocolate chip cookies that are not gluten-free and actually having the delicious vegan cookies that are not gluten-free. Because sometimes they're gluten-free, and that's kind of like not my jam, but I do like the vegan ones. So that's what I was thinking about while I was writing this. Okay, let's fix our scanfer. What are we doing? Is everyone having fun? I already asked that once. I'm seeming desperate. Don't appease me. Say you're not having fun. Yeah, that's what I like to hear. Okay, cool, fun. All right. Here's an XKCD. It is about how it is security relevant to make sure your buffers are the right size. Here is something you should be thinking about. I said 1, 2, 3, 4, 5, 6 requires 17 bits to store, and that should be a lot of bits. You have a question?
Have you defined what a buffer is yet?
It's an array. It's a Pythonic list. It's not a word that means anything. It's a high-level term that refers to the notion of a C array, but also could refer to other things. Yeah. I always call mine buffer. Like, I name them buffer. Okay, so if you are working with a C array and you start copying information into it, it might be too big or too small. And you need to think about this because of the infamous Heartbleed bug, which was, I think, the first really earth-shattering bug on the early internet. Though, like, not that early. It was Heartbleed, like, 2010 or something like that. You were all alive for it, probably. And you're practically babies, right? Some of you are not actually that much older than my cat, which I realized the other day, and that was intensely demoralizing. Any of you have cats? Do any of you have a cat that's older than you? A poor cat.
But he was older than, he was a chiller too.
Well, it will always be older than you, right?
Yes, he will.
That's the thing with birth dates. It's very hard to catch up. Okay. So this is the solution to the problem that I showed you. Use small arrays. Use arrays of size 1 or of size 0. And let's go ahead and start printing this value back. It looks like I'm missing a print statement there. There it is. So let's edit that in. A lot of people don't know this, but Vim is short for Vimium, which is like William. It rhymes. Here, it's spelled this way. Okay, scan. Why? I see. I know I can't type scan. Okay, let's print out the results. I'm going to do a new line. I'm going to treat myself to a little bit of new line. I really like those new lines, right? Some high-level languages have a built-in new line at the end of print statement that's actually really, really annoying to get rid of. And I really appreciate having control over the code that I write. So if I were to ever have to teach in a language where you couldn't turn off the new lines easily without implementing keyword arguments, that would be demoralizing for me. So I hope you all feel for me. Okay. A bunch of students in my CS 151 this term learned about the keyword argument for the terminating file at the end of print from ChatGPT on the print star. Remember that? Where you like print a series of asterisks, and they printed every single character individually. And it was actually kind of cool. I like that solution. Okay, so what are we doing? We'll print ab. How does gook work? Gook. That seems bad. Is this a disaster? Ooh, that's a little bit cooked. That seems bad. Wait a minute, I should read the warning instead of just inquisitively looking at my code, desperately trying to figure it out without enough context to understand it. Okay, let's see. This says my %d expects something of type int, but argument 3 has type int star. Oh, I'm a silly goose. And what do we do when we're a silly goose? We go honk honk. Everyone repeat after me. Honk honk. I cannot believe you did that. Okay. You can do whatever you want, but that was an obvious test. Okay. When I taught in North Carolina, I posted a video of myself. Have I told you all this? I posted a video of myself drinking pasta water on social media, and my students started doing it and posting videos as well. And I was like, no, your teachers are not cool. Like, don't be like us. Okay.
Oh, no, I'm being a social influence.
I know. I never wanted to be an influencer. Unless any of you have brand deals, you can send those straight to me. And if you are wondering which VPN I use, I will be able to tell you as soon as a check clears. So I'll keep you posted on that. So what have we done here? We've printed this out, and we can also print this out without the comma because we love those commas and those decimals, but sometimes we also don't. Wait, I deleted 2 things by accident? Okay. Oh, I'm pressing buttons. Oh, I never know what mode I'm in because I don't actually know how to use Vim. But it turns out it's so annoying to write C, it's not actually more annoying in Vim. That's what I noticed. I was like, can I not write this because it's in Vim? And then you open VS Code and you're like, nope, that wasn't the problem. Okay. There we go. We've done a thing, and we're proud of it. Okay. So this represents the difference between values and references. We saw what A and B are. Those are numerical values representing a place in memory, and they're representing a place in memory that I am allowed to talk about. We could do something a little bit interesting as well. We can change these to stars. Just nuke that line. If I do D3E, will that take the next 3 characters? That's not what I want to do at all. We're just going to go in insert and use deletes, because I don't know how to use them. I think this is fine. Okay. So let's we'll print them unsigned. Oh, I should put a space between them, right? Is that not what I should do? Why do I keep pressing the up arrow expecting it to do different things every time? Okay. GCC IU. No, stop. Slash. IU. Okay, all right. That's weird.
It looks like it still doesn't like the stars.
Yeah, I'm supposed to use %p. So the unsigned is a 32-bit type, and I'm on a 64-bit machine, so it doesn't want me to print that. And I think %p is the one that it is asking for. Let's see. But it's going to print these in hexadecimal. There you go. So we have discussed segmentation faults previously. This is address number 1000. That represents presumably 1000 bytes. How many of you have an operating system on your computer larger than 1 kilobyte in size? There's your segmentation fault, right? We found it. It's right there. It was staring us directly in the eyes, making good eye contact, like I don't do, right? I toured an engineering lab the other day, and the engineering manager there could maintain eye contact, and I forgot there were humans that could do that, which is pretty interesting. Okay, let's double our input. How many minutes do we have left? Okay. All right, so we're going to edit this over to having our buffers again. What? Are you saying something I should listen to?
We had an undo file set up for.
Oh, I bet if I just hit undo a bunch of times, it'll probably do it. I don't know either. I don't know how I would know that, because I've never tried to undo anything before, because I just do it right the first try. Okay, all right. So we're going to put this in A, and we're just going to put A plus 1 there, and we're going to bet it's going to work. Why wouldn't it? Don't think about that too much, but do think about what address that would represent in program memory. Okay, and then we're going to print, we're going to do some multiplications. Does that look like what I'm trying to do? I have a buffer of size 2. I put something in the 0th position and the 1th position. Then I multiply the 0th position times 2, and I multiply the 1th position times 2, and I print that out. Currently, I'm printing them as %Ps, and I want to print them as %Ds. Don't make a Ds joke. I realized I walked into that. Okay. Okay. So we're able to double numerical values like so, right? But that looks extremely wrong. Why is that wrong?
4, 6, 5.
Oh, that seems fine, right? Well, that's not very good for the example, but that seems fine. So if we do 1, 2, 3, 1, 2, 3, it's going to be 2, 4, 6, 2, 4, 6. But if we do 6, 6, 6, 6, oh wait, no, there might be people that don't like that in here. Okay, 7, 7, 7, 7, 7, 7. Okay. Oh, that's not how addition works. Gasp. Can I get some audible gasps from the audience? Oh, the horror! Oh, it's like when I watched Nosferatu 2025 and the director didn't understand the theme of the 1922 film, which is fine. I didn't either. This is bad and wrong. Why is it bad and wrong? Because we have to carry values. Do you all remember long addition? Does your heart secretly yearn for the simplicity of elementary school? What if in elementary school we had instead taught you binary arithmetic? Would you not now be happier in your life today?
Yes.
Exactly. Thank you. I love audience participation when it agrees with me and not otherwise. So here's an example of binary addition. We take binary value 1, 0, 0, 1. What number does that represent? It's this one. I have that down as 9. And then we take 0, 1, 0, 1, which is, wow, that's painful, which is this one, which I have down as binary, as a decimal 10. And we add those together, we should get 19. Uh-oh, we have a problem. 19 is definitely going to be a 1 in the ones place, because it's an odd number. 19 is about 16, which is 2 to the 4th. Yes, it's 4 squared, so it's 2 to the 4th. Come on, practice, grind. Get on that binary bit set. Okay. you don't have to laugh at that one. That one was pretty forced. Okay, so we have a 1. It's close to 16, so we take 16. 19 minus 16 is 3, so we have 1, 1, 0, and then we have a 1 in the 16th place. What this leads to is a complication, though, because we have two 1s, we're adding them together, and we're going to add them up, and we're not going to get a 1. So what do? We have to panic. We add an additional carry line. We populate the carry line by extending over to the 2 to the 4th place, 2 to the 4th being 16. If we have both a 2 to the 3rd and a 2 to the 3rd, that is represented with a carry bit of size 2 to the 4th, and we get 1, 1, 0, 0, 1, which I can't actually do on one hand, so that is this many. And I have written those out here with leading zeros to allow alignment, and you can also represent them in Python. Okay, this has to be in quotes, right? Print. Then we're going to print the binary value of OB 0. I was adding 9 and 10, right? Does this sound? Does this look like what I was doing? Ta-da! This one turns into this one. This one turns into that one. These two 1s, neither of them represent the presence of a 1 in the position 4. Which I'll term this position 4. We don't need a 0 or 1 index it, right? There is a 0 there, but we carry over into this leading 0 position, and then we get a 1 in that position, and of course the leading zeros are not necessary for this numerical thing to happen the way it does. I have spent an ungodly number of minutes looking at hexadecimal outputs of numerical computations that I didn't quite implement correctly, so I'm forcing you to stare at them with me as well. One of the things that's pretty cursed to look at here is if you start getting into indexing on these, it's going to get unpleasant really quick. One of the pernicious bugs I had in some of the stuff I was working on is I was printing things out in hexadecimal and they started with 0x, and 0 is a number, and x is not, and some of my testing scripts were reading the 0 and throwing out the x and being off by a little bit. Look out for that. What does this all mean? Next week we are starting SHA 256. I'm going to teach you what SHA 256 means on Tuesday, and then you're responsible for having it written by the following Thursday. While you are working on SHA 256, the bits in your computer are going to be in a different order than they are expected to be in by the SHA 256 algorithm that is implemented by everyone I have found. It is probably possible to transpose all of the operations to account for this reversal in bits, and I was unable to do it. It could be easy for you, it could be hard, I don't know. I used the solution of changing the order of my bits using similar bit operations that you're going to use on macros. SHA 256 is going to read in things in 32-bit words and then slice and dice them around in 8-bit chunks. Moving values in between having 4 8-bit fields and one 32-bit field is non-trivial because it is unclear what order you put those 4 8-bit chunks into the 32-bit fields, because we don't know if we put the 1's values or the 2 to the 24th values in first. This is similar to having 276, having the 100 in the zeros place. That's weird. The same weirdness happens with endianness. We can view a 32-bit integer as having 4 digits, each of base 256. And we're writing them in different orders. And that is a very weird way to think of this. It is a little bit easier if you think of them each as having 2 hexadecimal digits, and the ordering of those hexadecimal digits changing. There's a lab on this next week. I'm not going to ask you to think about that further right now. I want you to sleep on this before the lab. Okay. Let's look at casts. How did I manage to fit World of Warcraft Classic into these slides? They're owned by $1 trillion company now. Okay. I'm sorry. Obviously, my editor was supposed to take out the reference to World of Warcraft, but I'm my editor, so I'm bad at that. I find it very common to see 32-bit code around that is adapted for use on 64-bit devices. One of the most obvious examples of this is that I was printing out pointers just a moment ago with the %D format code. That was legal for many years because on 32-bit systems, pointers are frequently stored in size 32-bit integer fields. For whatever reason, as C progressed through the years, integers stayed at size 32 after beginning at 8 and then 16, but pointers have now progressed to size 64. So now pointers and integers are different sizes on most modern systems, but not all, and this is weird. It is hard to get old code to run. Some of you have followed with interest the efforts to get PlayStation emulating, working on modern devices, right? Bloodborne PC came out recently. Before that, we had Demon Souls. Historical games are very interesting. Vim, I believe, is based on the Ncurses library that was written for the very first text-based RPG, NetHack, which might actually not be the first one. I think Rogue was a little bit before it. And then Vim is based on the command for basically a typewriter command at the old AT&T Bell Labs that are the same people that put together GraphVis, right? So all of this backward compatibility stuff is going to follow us around until the end of time and torment us until we get used to it. So I want to motivate this 32-64-bit confusion. It is important, and it is mattered, and it is ludicrously obnoxious. I semi-regularly do use numbers that are too large to fit in the baseline integer type. One way to tell that you are working with these is if you do a lot of computations in Python, your code will actually appreciably slow down. My Python seems to be implemented with 30-bit integers with a little bit of nonsense in those last 2 bits. And so if I do a billion additions that are too big to fit in a 2 to the 30th integer, my computer slows down more than it would otherwise, right? In C, I can specify whether I want to use a 32, 16, 8. Every once in a while, you can use a 24-bit type, right? And I want to introduce the notion of the difference between the number 1, which is an abstract or Platonic ideal of 1, having 1 of something, and the integer or long or character value 1, which is a 1 with a fixed number of preceding zeros. It is different from integer 1. It is not an integer, it is something else when it is a computer. So the long 1 looks a lot like the integer 1, but it has different properties. And those properties come into view when we add it to numbers that are too large and we start to be exposed to the underlying implementation of the long type. So we can look at these 2 examples here. We have a long x, which is equal to 0, and we can have an integer y, which is equal to 10. Those things have different sizes. This is probably going to have 64 bits in it, and this is probably going to, the y is going to probably have 32 bits in it. If we want to store the numerical value y, which is an integer of size 32, in a variable of size 64, the conventional way to denote this, so that you know you're doing it on purpose, is with a cast. A cast is we take the name of the type to which we are trying to convert some value. We enclose the name of the type within parentheses, and we apply it as a prefix operator. So the notation is open paren, name of type, close paren, and then either the value or the alias. So I can do this with the value 1 here, and I can do it with the alias y here, and it will work the same way. Let's look at an example of this in code. I guess we'll keep working with scanf, because I'm emotionally attached to it now. I think what I do, I had long x equals 0, int y equals 10, x equals long y. I'm going to print, we'll do new lines between the, let's see. I want to print out x and I want to print out y. We should expect this code to draw at least 1 error. Why is that? I am using the %D format code to print out both a long and an int. Those are different types of things, and I am giving them the same format code to see. So I'm going to demonstrate what that error is going to look like with GCC scanf. I'm going to get a warning on the first of my %Ds, which is the one representing the x. The D format code expects an integer, but has been provisioned with a long int. That is too long, so I will simply specify that I mean a long by putting an L there. I can also convert these to hex, which some people like doing. Wait, did I go to encrypt that? Okay. Scamp.c, a.l. Okay. And we're able to see the numerical value. One of the things I noticed that is ludicrously confusing is if you do characters. So the character, we'll take A. The largest value for a character is 255. And I can take two characters that are each of size 255. I hate this, by the way. If I print A plus B, if I add those two character values together, I cannot get a number larger than 255.
It just caps and doesn't wrap around.
It will wrap around and it'll print as 244 because they're both equal to. But I do not like this very much. Okay, that's coming across as -2. And if I do, let's see, if I do unsigned, I just did an undo there. I don't know what I undid. Okay. There's GCC. Hayut. That is like really, really extremely wrong, right? There is casting all over the place in C, and things are usually getting cast into integers, which means I took two 8-bit values, 255 and 255, added them together, and somehow got a bunch of other bits involved in the mix. What I believe that is that is the unsigned value that represents the integer -2 value. Because I think I calculate character -2, and then C converts that to an integer -2, which is of size 32 bits, and then it converts that -2 to a positive value using the unsigned flag and gives me a bunch of garbage. You will see this all the time. If you print a decimal value that starts with 429, it is probably just some small negative value that you got by accident, and you didn't necessarily mean to be working with a 32-bit type. I don't think that will make, that doesn't make sense to you, does it?
If the number starts with 429, it's sus and it might be garbage.
It's pretty close to 32-bit max, right? How would I figure out if that is -2 in the integer size? I'd probably conduct an experiment. Cast it back to what? No, I'm intrigued.
Cast it to a sign and then print it as a sign.
I think I just say signed. I just say int, right? I have no idea what this is going to do because I don't know the associativity. Yeah, I mean, it's -2 something, right? Okay. Casts are weird. I have started using casts more on future assignments. I wanted to introduce them and get them used to them for now. Expect ints to be of size 4 bytes, longs to be of size 8 bytes, use standard int to be specific, and here's a fun fact. Are character values expected to be signed or unsigned? I have no idea. I have never thought about it. I don't know how you would find it out. I don't know what the format code to print a single character is. I use %C, and that does the ASCII representation, I think. So if you're using characters, just be careful. Here is an example I wanted to show of representing the ordering thing. I'm going to throw this into a new file. That work? Cat noof? Cool. All right. So let's step through this quickly. The first line of code here is I create an integer star. I want to represent that in terms of a similar idea in Python that we don't use that often. Oh, did I open command instead of terminal? I'm sorry. Okay. It is possible to say this in Python. X is a list of integers. I'm allowed to say that, right? And then if I go to use X, I get an error. The value of X is not defined. The only thing I have told the Python interpreter is the type of X. That is logically equivalent to this line of code. I'm saying X is the same kind of thing as a list of integers would be. But it is not necessarily any list of integers. It is just a name that I can use in the future to refer to a list of integers. It doesn't have some value into it until I use single equals assignment to assign it to a list of integers, right? And then we can view X and we can manipulate X as we would like to. Okay, so I'm creating a variable which I could use to store a list or buffer or array of integers, okay? In the next line, I am creating an array of 4 characters. This is slightly different from the star declaration in that I am requesting specifically to have enough memory to store 4 distinct characters at whatever location buffer is at. I represent this as, oh, there's a typo. Someone put that in Discord. Okay. I guess space is maybe the default character? I don't know what. Does this work? So I can create an empty list that has some positions. One of the benefits of this is if I say, hey, I want the third value of X to be 7, that doesn't work. But if I say, hey, I want the third value of buffer to be, and I'm going to respect that it's supposed to be a character, so I'm going to put the character 7 in there, that is allowed. Some of you have worked with initializing arrays before. I think it is uncommon for Python programmers to think about initializing their arrays. I initialize my arrays a lot in Python, and I just suspect it's because it's not my native language. I don't know that it makes sense to do. But you can use things like this. I know in NumPy people work with initialized stuff all the time because there's built-in methods to do it, and they wouldn't be maintaining those methods. So the NumPy zeros method creates an array of some size that contains only zeros, right? So we are accustomed from NumPy to initializing arrays. This is an initialization of an array. Okay. I take what I perceive as easy to recognize values. I take the hexadecimal value A, B, C, and D, and those are this many, I think, right? Because that would be F, yeah. So that is decimal 10, 11, 12, and 13. I can assign, some of you have seen this notation. That sketches me out a little bit. There's good reasons to be sketched out by that, and that's because you cannot do it except at the same time you are declaring the array for the very first time. The reason you can't do that is you don't know how big buff is when you do this, so this is not safe from a memory perspective. Because this is not always safe, I regard it as never safe, and I only ever assign arrays one at a time. The correct way to assign this, of course, is with a list comprehension. And a list comprehension in C is simply the for loop with the single line assignment nested inside of it. So look out for assigning values to arrays. I think there'll be a tendency to say things like, have some string and then like check to see if some string equals to some other s. That's not going to work very well in C. Just look out for that. I am creating this buffer. I am throwing A, B, C, and D in it. Those are numerical values, A, B, C, and D, and we can print them out in a variety of ways. Okay, let's do something unbelievably sketchy. I'm going to say, dear GCC, I am an evil computer science professor that is tormenting my students talking about integer encoding. And in order to make a very specific point that is important to me and perhaps not important to them yet, I need you to pretend that my character buffer is actually an integer buffer, and I need you to not complain about it. And so in exchange for me saying, I specifically want you to pretend that this is an integer star, I do not get a complaint. I was able to GCC this. I think probably if I do pedantic, maybe it'll get mad at me. No, I guess it's allowed. Okay. Let's go in here. And I think if I get rid of the cast, I will probably be in some amount of trouble. If I seemingly accidentally tell GCC that my buffer of characters is actually a buffer of integers, it will tell me, no, you silly goose, you told me that that was full of characters. But using the power of casts, so this is like being a wizard, right? We're casting spells. We're going to cast a spell on GCC that lets us write unsafe code that we should never write in real life, but we can write as a silly example in class. Okay, and that will all work more or less properly. Look out for getting these types of errors. Usually it means you're messing with things that are the wrong size. You should always add casts to your code so it doesn't create errors, and the cast is a form of documentation. We can print this thing out, and I have printed it out, and I have too many tabs open. Is that visible in the back? Who's back there? Tippy, can you read the bottom line there? Is that fine? Okay, thank you. I very specifically put A in position 0, B in position 1, C in position 2, and D in position 3, and also a bunch of zeros sprung up here. What's going on here? The 0th position in the 4 array bits is being represented as the least significant bit, which means that the least significant values come first, which means that if I were to stylize CS276 in the same style, I would write A6, A7, then A2, starting with the ones place, then the tens place, then the hundreds place. This is equivalent to beginning. This is the ones place. This is the 255th place. If I take just the 0 and the B, it's very hard to highlight. That is how many 255s we have. That is how many 255 squared we have. I'm not going to square 255 in my head in front of all of you. That's too much work even for me. It's 32,000. Okay, and then the D is the 255 cubes, which is 2 to the 24th, which is 1 million times 8, so that's the 8 millionth place. Okay? That is really weird. And also, like, maybe a little bit cool. I don't know. You can decide if you think that's cool or not. Did I not compile it again? I think I said I had a D, which I think is 14 in, excuse me, in the 8 millionth place. And 8 times 14 is probably about 21, right? How far off am I?
8, quite.
Yeah, that's pretty bad, huh? Oh well, we tried. What's 2 to the 24th? Oh, it's 16 millionths. So it's 16 times 14, which is just a little less than 255. Yeah, so that's about 220. So that does make sense. I don't know what my error was. I think I thought 2 to the 4th was 8 instead of 16. So that's like 220 million or something, right? Yes, that's approximately 220 million. Well, that's fun. That's like doing mental math. Okay. Here's your takeaway. The ways integers are printed and stored is weird. Do not trust anything. Use all this dumb nonsense with casts that we hate to figure things out. And now, just for a sweet little fun, itty-bitty, tiny, teeny bit of content at the end of class, I introduced you 2's complement. Some of you know what 2's complement is. Can you raise your hand if you know what 2's complement is? Okay, I taught this last year to more people than are raising their hands, and that means that I'm a bad teacher. Okay, which is, that's the name of a movie, right? There's a movie called Bad Teacher. It has Cameron Diaz in it, right? Okay, I bet it's a good movie. Okay, From time to time, we like to use negative values. Can I get some loud booing for negative values? Boo! Yeah, we can express everything we need as positive integers in modular arithmetic, right? Okay. But every once in a while, we want to do a subtraction. Can I get some loud booing for subtraction?
John, if you're adding that,
Okay, whatever. So there are integers and there are unsigned, no, these are not integers. There are ints, which are not the same thing as integers, and there are unsigned ints, which are also not the same thing as the naturals. Is 0 a natural number?
Yes.
Yes, because it's a computer science class. That's how you tell, right? It is context dependent. You look up your current context, and if it says computer science, 0 is a nat. And if it says math, then you have to be very careful, because the mathematicians will fight you over this, I have learned. I saw some mathematicians coming for me, so I had to buy time there. Okay. Here's a fun thing to do. Okay. What is the largest integer value? Well, we kind of saw it earlier. It's 42,000 something, right? Because 2 to the 32 is 2 to the 30th, which is 2 to the 10th to the cubed, which is a billion. So it's 4 billion or something like that, right? Okay. You can also just write this in a variety of ways. Here is a simple loop that loops until numbers stop getting bigger. We can run this quickly. I did this over characters, which is a lot more manageable. Let's take a look. Wait, what's in noof right now? I'm gonna just vim noof. No, I'm gonna nuke noof and then I'm gonna vim it. Okay. Then we're gonna vim. What does noof stand for? Yeah. Yeah. Okay. That. My naming scheme makes a lot of sense. Oh no, nothing's popping up. That's because I wrote a scan here and I'm waiting to scan something. So I need to provide a string. I wonder what string I'll provide. My favorite string is A, because it's alphabetically first. Okay, and I'm able to steadily see what values are increasing over time. And this is really cool and fun. Many of you have probably not seen the multiples of 10 before, so this probably seems really exciting to you, right? Well, I wonder what's going to come after 130. Oh my gosh, have we bamboozled ourselves? There's a bamboozlement afoot. These are the same value. One of them is being printed as a signed value, and one of them is being printed as an unsigned value. What this represents to me is the notion that somewhere in between 120 and 130, I encounter the maximal unsigned value for a character. I suspect, but don't know, I do know, that that is probably right around 2 to the 7th at 128 that this changeover occurs, right? You don't think so? Are you shaking your head at me?
I'm going to need to see some proof.
You're going to need to see some proof? So be it. Hopefully I have some on a success. Oh, look at this! This is the way to prove it. Okay. Create somewhere to store an integer, scan input into set integer, cast integer to a character and print, cast integer to an unsigned character and print. That seems like that would be the proof you're looking for, right? Well, not to worry. I have a plan. I'm going to rem noof, and then I'm going to vim noof, and then I'm going to paste, and then I'm going to say... sorry. What I meant was I know what I'm doing. Oh, no. Okay. I'm going to gook noof, and that... Nope. I'm going to gook noof. Oh, I can't say an F and a C next to each other. You see why I can't pronounce that, right? Okay. Yeah. You're students. You are allowed to do things. Okay. I'm going to consult the documentation. Fortunately, my code is self-documenting, so I can just look at the code itself. Okay. This is going to scan a decimal value, and it's going to print it as a... I'm assuming that stands for Helm Hammer Hand, because the D there is obviously Helm's Deep. So this is Helm's Hammer Hand Deep, which is obviously a reference to Lord of the Rings. This U stands for you, the viewer. Like, comment, subscribe. Okay, so I'm going to scan into an integer. I'm going to cast it to a char, and I'm going to cast it to an unsigned char. I like to think of those as like a holographic and a non-holographic Charizard, right? Okay. Are there any... Pokemon Still good, still cool? Charizard? Charmeleon.
Yeah, that's the one that everyone talks about.
Charmeleon's so.
I love Charmeleon. I actually don't have to pay to teach here. They let me do it for free. Okay, let's put in integer numerical value. Let's try 128. I was asked for proof earlier. Oh my gosh, that's exactly what I expected would happen because I already knew the answer. What happens if I put in 127? I wonder what'll happen. Oh my gosh, they're both positive. I bet the maximum positive value for an unsigned character is 127 and the maximum or the minimal negative value for a character is negative 128. Does this suffice as proof to your standards?
Absolutely.
Amen. Okay. That's what we like to hear. Here is the same example. Okay. What does this mean to us? Well, I like to think of negative 1 in 2's complement being the thing to which I must add 1 for which the result is 0. So I can take negative 1 and I can add 1 to that. And I can also say that 255 is also represented as negative 1. So what this means is that negative 1 should be similar to 255 in this sense. And that means 256, which is what I get if I add 1 to 255, should be represented by 0. And this is how modular arithmetic was invented. It did not exist before the C programming language, actually. Do not believe the mathematicians. They're trying to take credit for things that circuits do. Here's a series of examples. Let's put in 65536 and see what happens. 65536. Oh, that's 0. Ah! Sorry, what I meant was, that's fine. Okay. Yeah, I don't know. Fool around with this. Okay. Unsigned values are represented as this type of binary. Signed values just have a 1 in the most significant place instead of being able to go up to larger values. You can simply add, think of addition and subtraction as the way in which these are made to be negative values. One of the reasons to store things in 2's complement like this is apparently it makes multiplication easier. I tried to write a multiplication algorithm. It did not seem easy at all, but perhaps it is easier than the alternative. This is division, which is hard. So your task for the remaining 5 minutes of class is to get this code to run and form an opinion about it, or you can leave. I will walk around and talk to you. I will not be here Thursday. I hope you enjoyed thinking about bits for 90 minutes with me. I had great fun the whole time, so thank you. You don't have to clap every day. It makes it seem like you're desperate. Maybe you are desperate.